Final spin video. Spin, 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 spin. Okay. Except this time we're going to talk about the spin group in math. And I'm just going to make it up. I'm going to do it off the top of my head, so it might not be 100% correct, but hopefully it's the right idea. So to start, before we talk about the spin group, we have to talk about the pin group first. Pin group. Now, okay. So the pin group is the group of all of the possible reflections. So you can represent a reflection with a vector where you say like, okay, reflect this one and then turn it into, the opposite. And then like this vector would turn into this one. And so that you get a reflection, and then you can compose them. And there's this cool thing where if you have two reflections, if you do this reflection and then this reflection, you actually get a rotation, and that rotation is twice the angle. So it's like, and it's in this axis. So like in 3D space, we're in 3D now, it'll be, it doesn't matter if you start with like do these two reflections, it actually doesn't matter which two reflections you started with. You could do any of these guys and you'll get the same result. So you can imagine it sort of like spinning. It has to have a direction though, so you have to say which one you do first. So like if this one is 1, or if this one is the first one, and then this one's the second one, right? You'll get this rotation, and remember it's twice the angle that it does. And the cool thing is that if you then have so rotations are if you have two of them, or actually any even number. So the pin group is just the reflections, and then the spin group is just the even ones. So it's like you have an even number of reflections, then you get rotations. And the reason that it turns into a group is because if you have two rotations, right? So say I have this rotation, and then I have another one that starts like, let's say it's like here to here, right? So we've got these two rotations, and this one goes like choo 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 choo, and this one goes like choo 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 choo, right? So you got two they're not super lined up, but you see what I'm trying to say. And then what you do is that, remember, we can spin them in their little plane, and it's the same idea. So I'll take this one, and I want to spin it around the cursor. No, spin it around 3D cursor. There we go. Right, so you line them up like this so that they're lined up, and then these ones will cancel, because remember the arrows are actually reflections, and if you reflect the same way twice, right? If you reflect this direction twice, you get right back where you started, because -1 times -1 equals +1. That's a Ricky shout out. And so these two cancel, and so I will delete them. And now if you have composed these two reflections, now you get a these two rotations, and you get a new rotation that's like this, except for remember it's double the angle. And so you have a new rotation, and then this rotation is the same as any other one that would be drawn. Like all of these would be the same. So that's my rambling 5-minute attempt at explaining how the spin group works. A little bit more spinning, because I was supposed to spin for 30 seconds, but instead I spun for like 2 seconds, and talked about math. But it's the last day, so what are they gonna do? Fire me? That's it.